Good morning, children. Let us start the reset today for science 10th standard. In the previous class, we have learned the laws of motion, lesson 1. Okay, so that lesson some more we have to revise. So yesterday, in the previous class, we have learned some important questions, 1 words and 2 marks also we have learned. In the same way, today some questions, internal questions, some exterior questions also we are going to study. Okay, so definitions also there. In that questions, first we are going to learn what is equilibrant. What is equilibrant? The answer for this equilibrant is the page number 4. So in the previous class we have learned some 1 words and 2 marks and some big questions also we have seen. So today we are going to learn some interior questions and some 1 words also. So what is equilibrant? Okay, what is equilibrant? Some students know. Those who know, you can say along with me. Others, you have to learn them. A system can be brought to equilibrium by applying another force, which is equal to the resultant in magnitude but opposite in direction. Such force is called equilibrant. The answer is in page number 4, first column. You can see that paragraph, equilibrant. Okay, the letters are in block letters. So a system can be brought to equilibrium by applying another force which is equal to the resultant force in magnitude but opposite in direction. Such force is called as equilibrant. Okay, so all of you say along with me once more. A system can be brought to equilibrium by applying another force which is equal to the resultant force in magnitude but opposite in direction. Such force is called equilibrant. Okay, so don't forget that equilibrant is the equal force as this resultant force and opposite direction, and it is acting in opposite direction. So it is called equilibrant. Okay, so the next question. The next question, what is moment of force? Okay, the answer is in page number 5. First column top you can see. Moment of force. The first 3 lines you see. Moment of force, otherwise called as torque. Okay, the formula for this torque is tau is equal to F cross B. Okay, F into B. So the SI unit of this torque is Nm. This torque is otherwise called as moment of force. Moment of force is otherwise torque. Okay, tau is equal to F into D. Okay, SI unit of this torque is Nm. Okay, so what is moment of force? The rotating or turning effect of a force about a fixed point or fixed axis is called moment of force about that point or torque. Okay, so learn well the rotating or turning effect of a force. Because of force, if there is a rotating or turning effect about a fixed point or fixed axis, that is called moment of force or torque. Okay, so that we can measure this by the product of force and perpendicular distance. This is the distance. F is the force. Product of this torque we can measure by the product of force and the perpendicular distance between the fixed point or fixed axis and the line of action of force. Okay, so this is what? Torque. Next, coupled. First, second, torque. What is moment of force or torque? Next, third question. What is couple? Define couple. This define couple yesterday we have learned along with the moment of couple, but we can answer this separately also. What is couple? That for that and this question you can write this answer. Two equal and opposite forces applied simultaneously at two distinct points constitute a couple. That answer is below that moment of force. You see, what is couple? Two equal and opposite or unlike parallel forces applied simultaneously at two distinct points constitute a couple. Okay, so that here this moment of couple for this couple only, couples rotating effect only we can say as moment of couple. Okay, so this moment of couple we have the formula for moment of couple. M is equal to F into S. Okay, F is the force. S is the perpendicular distance between the line of action of the forces. Okay, so the moment of couple, the unit of this moment of couple is Newton meter. The unit of this moment of couple, SI unit of this moment of couple, Newton meter. Okay, so this the unit of moment, SI unit of moment of force also Newton meter only. The SI unit of moment of a couple also SI unit. The SI unit of this moment of couple also Newton meter only. The SI in SI system, this Newton meter is in SI system. In CGS system we can say this as dyne centimeter. This one SI system. CGS system. In CGS system we can write as dyne centimeter. Okay. In SI system the unit is Nm, Newton meter. In CGS system the unit is dyne centimeter. Okay. So all of you know this. So once more learn well. Next definition we can learn force. You know force. What is force? Different types of forces in the previous classes we have learned. So here the force. What is force? This force has the unit SI unit. The SI unit of this force is Newton. Okay. What is 1 Newton? What is 1 Newton? That question, what is couple? Define 1 Newton. Or we can write that is 1 Newton. Okay. So what is 1 Newton? The amount of force required for a body of mass 1 kg produces an acceleration of 1 ms per minus 2. Okay. That definition is in the page number 6. Second column, last part we have. Okay, we have in the last part. So what is 1 Newton? The amount of force required for a body of mass 1 kg produces an acceleration of 1 ms per minus 2. So this 1 Newton we can represent as 1 kg ms power minus 2. Okay, this 2 the 1 Newton is equal to 1 kg ms per minus 2. Okay, then for this Newton is the SI unit. Then dyne is the CGS unit of force. Okay, so what that define 1 dyne. Next we have to define 1 dyne. Before that, once more we can repeat this. Define 1 Newton. What is 1 Newton? You all of you say along with me. The amount of force required for a body of mass 1 kg produces an acceleration of 1 ms per minus 2. Okay, that is 1 Newton. Now 1 dyne. Define 1 dyne. The 1 dyne. The amount of force required for a body of mass 1 gram produces an acceleration of 1 centimeter s per minus 2. Okay, that is 1 dyne. Here 1 Newton is equal to 10 power 5 dyne. This values you have to know well. For 1 bars also you can use this. Okay. So define 1 dyne. What is 1 dyne? The amount of force required for a body of 1 gram produces an acceleration of 1 centimeter cm per s per minus 2. 1 dyne. 1 Newton is equal to 10 power 5 dyne. So here 1 dyne is equal to 1 gram s power minus 2. 1 gram centimeter s per minus 2. Okay. So kilogram in SI unit, kilogram, that is changing into gram in CGS unit, then meter changing into centimeter, second only. Okay. So we can repeat it once more. Definition of 1 dyne. The amount of force required for a body of mass 1 gram produces an acceleration of 1 cm s per minus 2. Okay. So that is 1 dyne. Next, unit force. What is unit force? Unit force. The amount of force required to produce an acceleration of 1 ms per minus 2 in the body of mass 1 kg is called unit force. So continuously we can see this next page, page number 7, top, first paragraph. The amount of force required to produce an acceleration of 1 ms per minus 2 in a body of mass 1 kg is called unit force. Okay, all of you understood this. Next, gravitational unit of force given. So in gravitational unit of force we can get the SI unit. The SI unit of gravitational unit of force is kilogram force. So this like this, and 1 batch you can underline in your book itself. So kilogram force. So kgf, that kilogram force we can represent as kgf. Okay. So in CGS system we can say this unit as gram force. So that is GF, gram force. Okay. So 1 kilogram force is equal to 9.8 Newton. How it is coming we can see. One kg force is equal to 1 kg into 9.8 ms per minus 2. So equal to 9.8. 1 gram force equal to 1 gram into 980 cm s per minus 2 is equal to 980 dyne. Okay. This is the representation of 1 kgf and 1 gram force. Okay. Next, define impulse. Define impulse, or then define impulsive force. Okay. First we can learn define impulsive force. What is impulsive force? A large force acting for a very short interval of time. A large force. All of you say along with me. A large force acting for a very short interval of time is called as impulsive force. Okay. So next, once more we can see. We can say together, a large force acting for a very short interval of time is called as impulsive force. Okay. Next, what is impulse or define impulse? Impulse is the product of force and time. Okay, we can define this as Okay. So the SI unit of this impulse is NS. Newton second. The SI unit of this impulse. So kg m s per minus 1. This is also equivalent to this NS only. So kg ms per minus 1. This is the unit of impulse. Okay. Next. What is page number 8? The first column, last you see, define law of conservation of linear momentum. This question, this 2 mark is included inside this big question. Okay. So, what is law of conservation of linear momentum? In the absence of external force, the algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum before collision. This is the definition for law of conservation of linear momentum. Okay. So, the definition asking time, this paragraph you can write. So, in the absence of external force, the algebraic sum of the momentum after collision is numerically equal to the algebraic sum of the momentum before collision. Okay, all of you understood? So, these questions you learned well. Next, in the below rocket propulsion, the same page, second column, second paragraph last, we can see what is escape velocity here. What is escape velocity? The velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Already we have marked. So that part you taken, you say along with me. The velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Okay. So say once more. The velocity which is sufficient to just escape from the gravitational pull of the earth. This velocity is called escape velocity. Okay, this velocity is very important in rocket propulsion. Okay. The next page, page number 9. Last part we can see. The mass of the earth, that values also have to know the value. You see, m is equal to 5.972 into 10 power 24 kg. What's the value of the mass of the earth? This one important for one word. M is equal to 5.972 into 10 power 24 kg. Okay, that one you have to underline. The next. Page number 11. What is weightlessness? What is weightlessness? When the person in a lift moves down with an acceleration equal to the acceleration due to gravity, that is when A is equal to G, this motion is called free fall. Here the apparent weight of the person is 0. In this condition or state refers to the state of weightlessness. Okay. Listen children, this paragraph we have learned already. So this paragraph we have to know well. This question is very important. Okay. Yesterday whatever given, everything you have learned I think. So today whatever given, that one also you have to revise well. So when the person in a lift moves down with an acceleration equal to the acceleration due to gravity, when A, that is when A equal to G, this motion is called as free fall. Here the apparent weight of the person is 0. This condition or state refers to the state of weightlessness. This is called as weightlessness. Okay. So like this, in the next page number 12, there are 5 points. We know the question, Roman number 8, 7th question. Give the applications of universal law of gravitation. In the previous class we have learned the universal law of gravitation. Can you say along with me? What is universal law of gravitation? Every particle of matter in this universe attracts every other particle with a force. This force is directly proportional to the product of their masses and inversely proportional to the square of the distance between the centers of these masses. So the direction of the force acts along the line joining the masses. Okay. So this is the universal law of gravitation. This universal law of gravitation otherwise called as Newton's law of gravitation. So in Roman number 8, 7th question, give the applications of universal law of gravitation. That answer is in the page number 12, the last page. Okay. So that 5 points are there. What are the 5 points? First point, what it is saying? Dimensions of the heavenly bodies can be measured using the gravitation law. Mass of the earth, radius of the earth, acceleration due to gravity can be calculated with a higher accuracy. The higher accuracy we can find out this radius of the earth, mass of the earth and acceleration due to gravity using this Newton's law of gravitation. So, okay, these are the dimensions of the heavenly bodies. Okay, next second point, what it is saying? It helps in discovering new stars and planets. This Newton's law of gravitation helps in discovering new stars and planets. That is the second point. The third point, what it is saying? One of the irregularities in the motion of the stars is called orbit. You underline that word. That word is very important for one word. Lead to the disturbance in the motion of planet nearby. In this condition, the mass of the star can be calculated using the law of gravitation. Okay. The fourth point helps to explain germination of roots is due to the property of geotropism, which is the property of a root responding to the gravity. Okay, in germination of the roots, this law of gravitation we are using. The last, fifth point helps to predict the path of the astronomical bodies. Okay, what is the last point? It helps to predict the path of the astronomical bodies. Okay, like this 5 points are there. These 5 points are very important. Okay. Then children, you listen. Answer in detail. In answer in detail in the book bag 7 questions are there. What is the first question? What are the types of inertia? Given an example for each type. Okay, what is inertia? And for the types are there. The types you have to know. Then the examples for each type you have to know. Then second question. What is the second question? State Newton's laws of motion. There are 3 Newton's laws of motion. What are they? Newton's first law, Newton's second law, Newton's third law. About these Newton's laws in the previous class we have learned. Third, deduce the equation of force using Newton's second law of motion. Okay, that is in the page number 6. The answer is in the page number 6. A small derivation is there that you have to know. Okay, next, in the fifth question is describe rocket propulsion. Okay, this rocket propulsion only escape velocity is there. About the rocket propulsion, 2 paragraphs. The answer is in 2 paragraphs. You have to know thoroughly. The 6th question is state the universal law of gravitation and derive its mathematical expression. Okay, state the universal law of gravitation and derive its mathematical expression. You know, universal law of gravitation, the expression they have given continuously in the page number 8. Okay, the value of this universal law of gravitation is 6.674 into 10 power minus 11 nm square kg power minus 2. That is a SI unit. Yes, SI unit nm square kg power minus 2. The value of this universal law of gravitation is 6.674 into 10 power minus 11. Okay, so the final equation F is equal for this universal law of gravitation. Capital F is equal to capital G into small m1 small m2 divided by r square. That is the final expression for this universal law of gravitation. How it is coming? Yesterday we have done, in the previous day we have derived how to know by. Okay. Next, in the last 7th question, give the applications of universal law of gravitation. So now here we have seen the 5 applications. There are 5 applications. The application first one saying it is used to find out the dimensions of the heavenly bodies. Dimensions mean what is the meaning of dimensions? Mass of the earth, radius of the earth, acceleration due to gravity. Okay, the high accuracy we can find out. The second point, it is helping in discovering the new stars and planets. Okay, so we can find out the irregularities in the motion of the stars. The fourth point, it is clearly explaining the germination of fruits. The fifth point, the path of astronomical bodies predicted by this Newton's law of gravitation. Okay. Next, hard questions are there. The hard questions also you have to know, and problems. Solve the given problems. Roman number 7, solve the given problems. And Roman number 5, assertion and reason as the following. State whether the following statement are true or false. These questions is important. You have to know thoroughly. When as like this, page number 12, we have the solved problems. There are 3 solved problems. That solved problems also you have to learn well. Yesterday, half part. The previous day you have learned half part. In the remaining, whatever yesterday not completed, you have to learn within this day. Okay, problems and all you have to do in the note. You don't read, you take the note and do the problems in the note. Practice well, understand the question, then you have to do the problems. Okay, so in same way, yesterday some problems we have, some questions we have learned. So what is inertia? The inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force is known as inertia. Okay, so children, you while studying, after finish this, while if you are studying this question and all the pages line by line you have to read and underline the important words, scientist name and important technical words, everything underline and study for the one words. Okay, so you have to know well this lesson. In the next day we can start the next lesson. Before that you have to learn this thoroughly. Okay, you have to know this lesson thoroughly. So learn well. Problems also learn well. Conceptual questions also you have to know well. Thank you.